Okay, so for the second part of this assignment, what we're going to focus on is we're going to be focusing on picking up on, excuse me, concentrations or clustering using point data, and we're going to do that two ways. One is analytically, where we will compute what's called the nearest neighbor analysis, and there are actually two ways that we can do this. And I'll go over both quickly, but for the purposes of the assignment, the first way that I show you that reports um, the expected mean, the expected distance, the observed distance, and the um, z value will be the one that you will need to report. So in order to conduct the nearest neighbor analysis, and again, this is a global test for clustering or whether or not the events occur closer together than would be expected, we will go over to the vector window and then analysis tools. And then here you'll see nearest neighbor analysis. We want to make sure that we click on all crimes and we run this, and there aren't terribly many points, so it should run rather quickly. Close this and it should give us a link here, and we take a look at it, and what you will see is a number of pieces of information are reported. We have the observed mean distance, meaning how close together on average were these events. This value here, the expected mean distance, is how far on average would we expect them to be, were they to be distributed equitably or randomly across space. And then here we see we have this nearest neighbor index, and you can calculate that by dividing the observed mean distance by the expected, and you get this nearest neighbor index. For our purposes, we're going to interpret the z-score, and again, when we have values, z-score values that are negative, that means events happen closer together than would be expected, or the expected mean distances are smaller than the observed mean distances are smaller than expected. And then this z-score gives us information about whether or not that finding is statistically significant or statistically meaningful. And when we look at this number here, we are going to compare that to what are called the critical values. And critical value are those that when exceeded, there's indication of statistical significance, or that we can reject the null hypothesis of spatial randomness. And so the cutoff values are for an alpha level of 0.05 or a 95% confidence level. The critical value that we're going to compare that to is 1.645, and when we use a 99% confidence interval, we're going to use a comparative value, critical value of 2.58. And so what we see here is that in this case, in either case, we are going to reject the null hypothesis of spatial randomness. I think I misspoke. The critical value for an alpha level of 0.05 is 1.96. The 1.645 value is for a one-tailed hypothesis test. So forget all that. Again, the cutoff values that we're going to use for comparison are alpha level of 0.05. We're going to use 1.96, an alpha level of 0.01. We will use a cutoff value of 2.58. So in either case, we will reject that null hypothesis here. So in the next part of the assignment, it asks us to create heat maps or kernel density maps, which pick up on areas that are, picks up on the intensity of an event across space. In order to do that, we will click on symbology, and then at the very bottom, you should see an option here that says heat map. and we will use that. We can change this unit here. We are going to use pixels in the assignment, and I think we set this to 25. We can change the color that we would like, and once we apply this, what we see here is that we do see areas that have more intense areas of concentration. But what we lose in this map initially is the context, right? We can no longer see the outline of the underlying layer, right? We see it that there are areas of intensity, but we can't really place where. And if we were to move the census layer up, it doesn't solve the problem. So what we have to do in this case is, again, we're going to open up the symbology, and when we pull this, when we pull this color ramp down, we click on it, what you'll see is there's this opacity value here, and that's gonna, we can set that, and so that will allow us to see through the heat map layer, right? And it kind of washes out the values where intensity isn't as great. And again, it shows us where those values are. So that's the heat map. I also asked that for the purposes of this assignment that you change the background to white, but that's pretty easily done, as we've done that a bunch of times. So again, for the clustering tests where we use point data, we're going to do this in two ways. One, we are going to conduct a nearest neighbor analysis. In the second part, we're going to create these heat maps, and just as a way to confirm that there's nothing strange going on, we can add back the crime data, and what we should see is that the points match up with the areas of intensity. So and in fact, we do see evidence of that. Again, for the assignment, I'm not asking that you include the points. I'm just saying for your purposes, what we can, just to verify that there's nothing strange going on in the map, I always like to add the points back just to be absolutely sure. Okay, so that's part 2 of the assignment. And that concludes all of the analyses that we're going to be using for the purposes of the point level data. And so for the next part, what we're going to do is switch gears, and we're going to be talking about testing for clustering using GeoDA and Polygon